Dear students, welcome to the video implicit differentiation. All the functions you have differentiated so far, y was explicitly defined in terms of x. Actually, y was the subject as you see here. And you have used different laws that you have learned, product rule, quotient rule for exponential trigonometrical functions to differentiate. But sometimes you cannot separate y and x from each other. For example, you have 2xy minus sine of xy is equal to x squared. Now here you cannot make y the subject. Such functions are called uh, implicitly defined in terms of x and y. In this section of this chapter, we are going to learn how to actually differentiate these functions which are implicitly defined. In this topic, in this concept, product rule and chain rule are extensively used. Now let's see some examples concerning implicit differentiation. Example 1. Differentiate each of these expressions with respect to x, y cubed. Now, when you want to differentiate with respect to x, so here for y cubed, chain rule must be implemented. So if you want to differentiate y to the power of 3, so we know that for the chain rule, power, then differentiation of y, so I write y prime, then y to the power of 1 less 2, or you can write, for example, 3y squared dy dx. It is another notation can be used. Now for part B, for x squared y5. Now here product rule must be implemented, so because you have two expressions, so if you want to differentiate d dx for x squared y to the power of 5, if you remember, product rule says differentiation of the first function times the second function plus differentiation of the second times the first one. So differentiation of 4x squared is 8x multiplied by y to the power of 5 plus differentiation of y to the power of 5. For y to the power of 5, you should use chain rule. So it would be 5 y prime or dy dx y to the power of 4 times the first function, 4x squared. Now it will be 8x y5 plus here you have 4 times 5, 20 x squared y to the power of 4. For y prime you can write dy dx. It is for the second one. Now for the C part, you want to differentiate x cubed plus 5xy is equal to differentiation of x cubed is 3x squared plus, now differentiation again product rule, differentiation of 5x, I separate them, 5x and y. It will be 5 times y plus differentiation of y. Differentiation of y is y prime times 5x. So it simplifies to 3x squared plus 5y plus 5x. You can write dy dx for the third part. Example 2. Find dy dx for the curve x cubed plus y cubed is equal to 4x y. Hence, find the gradient of the curve at point 2 and 2. Now, we want to use implicit differentiation to differentiate this expression. Differentiation of x cubed, so it will be 3x squared plus differentiation of y cubed, it will be 3 y prime y to the power of 2 is equal to, here product rule must be implemented. Differentiation of 4x is 4 times y plus differentiation of y is y prime times 4x. Now, so it will be 3x squared plus 3y squared. Instead of y prime, I write dy dx is equal to 4y plus 4x dy dx. As it wants you to find dy dx, I need to make it the subject. I transfer 4x to the left hand side, 3y squared dy dx minus 4x dy dx is equal to 4y minus 3x squared. So dy dx is factored here. So it will be dy dx 3y squared minus 4x is equal to 4y minus 3x squared. So to find dy dx, I will write 4y minus 3x squared over 3y squared minus 4x. It is dy dx. Next part wants you to find the gradient at points 2 and 2. So just replace. So n will be 4 times 2 minus 3 times 2 to the power of 2. 3 2 squared minus 4 2. It will be 8 minus 12. Here will be 12 minus 8, which is minus 4 over 4, giving you an answer of negative 1. Third example, the equation of a curve is 3x squared plus 2xy plus y squared is equal to 6. Find the coordinates of the two stationary points on the curve. So in order to find the stationary point, we need to find the points for which dy dx is equal to 0. So first differentiate. Differentiation of 3x squared is 6x plus here product rule. Differentiation of 2x is 2 times y plus differentiation of y is, I write dy dx times the first one, which is 2x, plus differentiation of y squared. Chain rule must be implemented. It will be 2 y prime y, so I write y dy dx instead of y prime is equal to differentiation of 6 is 0. So I make dy dx the subject is equal to, first let me factor it. Dy dx is 2x plus 2y is equal to, if I transfer to the other side, minus 6x minus 2y. So dy dx will be, they both have minus 2 in common. I factor it, minus 3x plus y over, they have 2 in common, x plus y. 2 cancel out each other, so it will be negative 3x plus y over x plus y. It is actually dy dx now. So we should find the roots. So we should put it equal to 0. So when it is equal to 0, the numerator must be 0, 3x plus y must be 0. Or you can say y is equal to negative 3x. Now you have one equation with two unknowns, but the second equation, we know that this point satisfies this curve. So replace it. 3x squared plus 2x. Instead of y, I put negative 3x plus negative 3x. S squared is equal to 6. So it will be 3x squared, 6x squared, 9. So 3x squared minus 6x squared plus 9x squared is equal to 6. So it will be 6x squared is equal to 6 divide by 6, then square root, x will be positive, negative 1. So if x is 1 and you replace in the equation, y will be negative 3. So it is the first point, 1 and negative 3. And if x is negative 1, y will be positive 3. So the second stationary point is negative 1 and positive 3. These are the two stationary points. Thanks for watching this video.